Hey everyone, here's our next lesson on completing the square for equations of circles. This combines our latest topic on equations of circles and an older topic, completing the square. So this is lesson 10.1.2. So some prior knowledge that you need to know for this lesson is two things. One is the equation of a circle, the formula for equation of a circle, which is in graphing form. So here we have our x minus h squared plus y minus k squared plus r squared, which remember comes from the Pythagorean theorem, where h and k represent our center of the circle, where the circle is located, and then the size of the circle comes from r. So not r squared, but r. So if, for example, this was r, if this was 16, if r squared was equal to 16, then that means r would equal to 4. So we'll practice some more of using the equation of a circle in this lesson. The other topic that you need to remember is completing the square. So here's an example and a visual of what we've done before. So in this example, I have x squared plus 6x equals to 7. And if I want to write this in perfect square form, or maybe if I wanted to graph this quadratic, I could use completing the square, or maybe I just want to solve for x. So what completing the square is here's a visual of it. It's actually putting down all, let's say, these tiles to represent the equation. This is our x squared and our 6x's. Our goal is to complete the square. So you could tell there's a missing portion of it. So this represents the x squared plus 6x's, and then that equals to 7. So if I want to complete the square, then I would have to add 9 little squares here that will help us complete the entire square. Alright, so by us adding, if we add 9, it completes a square, which also means if we add 9 to this side, we also have to add it to the other side, so it stays balanced. Another shortcut to this that we might remember is, why is it 9? It's 9 because 3 times 3 gives you 9, and this 3 came from this 6. Alright, so if you take the 6, you divide it by 2, and you square it, you actually make a square of it, it gives you 2. So half of 6 is 3. 3 times 3 gives you 9. Alright, so once it's a perfect square, then that means our dimensions are x plus 3 and x plus 3, which would be x plus 3 squared. So now we've rewritten the statement, and then of course the 7 plus 9 turns to 16. So this is what it would look like algebraically, and then below it is that just the visual, if that helps you. If you're still struggling with completing the square, you might want to look back at the previous lessons we've done with the quadratics. Earlier in this semester. Alright, so here on problem 14, we're looking at the equation of a circle, but not only in graphing form that we just finished learning, but also the general form, which is not very friendly for graphing. So let's first start with the graphing form of this. So this is assuming we have a circle given to us. With this circle comes a bit of information. So if I look at the coordinates of the center, it's at 3, 1. And the length of the radius is given to us, which is 5. I've already labeled that for us. So center and radius, and we're going to plug that into our formula for graphing form of an equation. So the nice part here is really we just have to copy the numbers that are given to us. So we have 3 and 1 is the center, so I'm just going to put 3. Let's do 3 and 1. And radius in this case is 5. And that's pretty much it. We could rewrite it, we could simplify it a little bit more. If I rewrite this, I would probably write it so that the 5 is squared, and then that would be a good way of finalizing the graphing form of a circle. So that's nice, but sometimes to do more algebra work, we prefer it in general form. So the best way or the easiest way to do that is to start with your graphing form and turn it into general form. And basically what you're doing is we're just going to multiply all this out and make sure we end up with our equation equal to 0. So I'll do that for us. So I'll start with the graphing form. So y minus 1 squared equals to 25. And so I'm going to start by multiplying out the first part. So this first part. And then we'll continue on to the second part. So the first part is just the x's. So I'm going to multiply that out. So this is going to turn into x squared minus 6x plus 9. And so that is the same there. And then the second part is just our y's, so we're going to multiply that out. Y minus 2y plus 1. Oops, I don't need the parentheses. Y squared minus 2y plus 1 equals to 25. Alright, so and then the second part is just our y's. Alright, so that's what it would look like if we multiply that out. If you don't remember how to multiply that out, you might want to use the box method. We've done that before. X minus 3, x squared plus 9 minus 3x, alright, etc. Alright, so moving forward, it's a lot closer to the general form, except you'll notice we have the x squares and y squares together, then the x, then the y, and then any remaining numbers. Alright, so let's combine like terms and move things around if we can. So we want x squared plus y squared, and then the x's, and then the y's, and then the numbers equals to 25. So the only thing that's left for us to do is to set this equal to 0. So I'm going to subtract 25 from both sides. And so that will leave us with x squared plus y squared minus 6x minus 2y minus 15 equals to 0. And that would give us our general form that we're looking for. Alright, so two-step process. Hopefully you could find graphing form easily using your center and radius. And then there we're just multiplying it out to get to general form. And then rearranging it, so make sure it's in that format. It does have to be in that format to be identified as general form. Alright, so now that's one way, but what if we're given general form and we want to go back to graphing form? So this is where our completing the square comes in. Alright, so I have a good chunk of this worked out for us. So I'll zoom into this. Alright, so here we have our equation, x squared plus y squared plus 4x plus 2y equals 11. This is what we're working with. General form, even though it's not equal to 0, but it's we can move that. So if it's not equal to 0, then the first thing I would probably suggest is move that number over so that we could do the following. Alright, so just like before when we multiplied our x's and y's separately, we're going to focus on completing the square with x's and y's separately. So I've kind of separated the colors here. So I have my x's together, so x squared plus 4x, and I have my y's together, y squared plus 2y. Alright, you'll notice I put these blank spaces here. This is to remind me this is not a complete square. Alright, so there's still a piece missing in order for me to complete the square. I'm not going to go over the visuals of this, but hopefully you remember, or you can look back at the previous example. But what I'm looking to do is complete the square, figure out what numbers go here, and then add them. So the shortcut we talked about earlier was if I take the 4 and I divide it by 2 and square it, that'll give me the number that'll help me complete the square. So this missing number then becomes 4, which I've already put down here. Same thing with the y's. Half of y is, or half of 2 is 2. Or I'm sorry, half of 2 is 1, and then 1 squared will give you 1. Alright, so since we're adding 4 and 1 to complete the square, we're going to also have 4 and 1 on the other side as well. So since these are perfect squares, we could write them as perfect squares, and then we combine like terms, which gives us the 16. 11 plus 4 plus 1. The reason why we want this in general form, this is a general form, or I'm sorry, graphing form, I should change that. So graphing form is so that we could identify the center and the radius easily. So you'll notice it's a plus 2 here, but that means your h is negative 2, and it's a plus 1, which means your k is a negative 1. So be careful there when we write our center. So because we have that, we could do a little sketch, and so I'm going to try to sketch this really quick. So if I have negative 2, negative 1, negative 2, negative 1 is right here. So this would be the center. And then radius would be 4. So I'll go 1, 2, 3, 4 in both directions. 3, 4 in both directions. 1, 2, 3, 4. And 1, 2, 3, 4. So 4 units in every direction. And then we should hopefully be able to trace a circle, something like that. Alright. And that would be an idea of what the circle looks like. Alright, so let's see if you could try that on your own. You might want to review that. Here's the next problem where we want to rewrite it in graphing form and sketch. So if you want to try this on your own, this would be a good time to probably pause it and see if you could do this on your own before I kind of show you how I would do this. So I'll give you a second to pause. Alright, so hopefully you've made an attempt to do it. If not, that's fine. We're still learning this. So the first thing I notice is this is in general form, which means I'm going to have to reorganize this so my x's are together and my y's are together. I also see that there's a minus 3 here. I'm going to try to push that to the other side so that that'll probably contribute to the radius that we're going to get later. Alright, so here I go. I'll zoom into this. So this is going to be x squared minus 4x plus some number plus y squared plus 6y plus some number equals to 3 plus those two numbers. All right, you'll notice I added 3 to both sides. All right, so this is where we do the completing the square. So I'm going to take negative 4 divided by 2 squared, which is going to be 4. And then I'm going to do the same thing, 6 divided by 2 squared, which is 9. So I'm going to add 4 and 9. All right, which means those are perfect squares. So I should be able to write this as x minus 2 squared. You'll notice it's a minus 4, so this becomes a minus 2. It'll be half. So this is going to be plus y plus 3 squared, right? Half of 6, half of positive 6 is positive 3. And then on the other side, we're left with 3 plus 4 plus 9, which is 16. All right, that's graphing form for us. So that's nice. And the only thing left is, if we're going to sketch this, we're going to need the center and we're going to need the radius. So center's at 2, negative 3. You'll notice the change of sign. This is a 2. We're paying attention to that positive 2. And then this is going to be a negative 3 because it's supposed to be y minus negative 3. All right, and then since this is 16, that's really our r squared. R squared equals to 16, which means r must be equal to 4. All right, so r is 4. So that should be enough to sketch this out. So I'll start with 2, negative 3. 2, negative 3 is about here. Here's the center. And then the radius of 4. 1, 2, 3, 4. 2, 4. Both 4 in both directions, left and right, top and bottom. And that should give us all right, something like that. And this is a sketch, so it doesn't have to be perfect, but it should give you a general idea of where it's located, right? Which we said was at 2, negative 3. 2, negative 3 is the center, and we have an idea of the radius. So we could do, this is a radius of 4. All right, so that's pretty much what you need to be able to do. If you were getting a test question, most likely be something like this. I could give you it in general form, say convert it to graphing form, which shows me you know how to do completing the square. Can you pull out the key information, center and radius, and can you take that and graph it? All right, so this is a good test question if you were going to get that. And that's something that'll take with you in the higher level math classes. All right, so the last question, I won't work this out with you, but I will show it to you in case you want to try this. If you could send me questions if you have some. But for the most part, we have 2 circles. And what you would need to do is, we want to see where these circles intersect. You could use your algebra skills, and I'll give you a hint there. They're both equal to 0, which means you could set them equal to each other. All right, so I would probably take all this and move it over here, and then certain things will start to get eliminated, right, which will be really nice. The other way is to graph these, right? Really the point is we want to see, can you write this in graphing form, both of these, and then when you sketch the circles, you'll have a circle and then another circle, and we want to see where they intersect. All right, so what are the coordinates of those? So go ahead and give that a try. If you have questions, let me know. If you need to see the answer to that, go ahead and email me or send me a message. As usual, you want more practice, there's the review preview section, which is from problems 18 to 25. There are math notes in this section. They remind you of the equation of a circle, which we kind of went over earlier, but it might be worth looking at if you have your book. And everything else, as usual, is a good review of prior topics. And so this is the end of the lesson. Let me know if you have questions or concerns. All right, have a good day.